All right, back to my notes.
It's amazing how people.
Next thing we want to talk about are loops. Get those out of the way. Again, I'm going to hit them pretty quickly because there's not really too much new here. Most commonly used loop in object-oriented programming is a for loop. The for loop allows you to step through using usually integers, step through every item or do a piece of code over and over and over again, in this case, 100 times. Defined an integer c, started it at 0, initialized it to 0. Keep going as long as this condition is true. Every time you hit the bottom of the loop, come back up, do this piece of code. Remember the plus plus means bump c up by 1. And then immediately check the condition to see if it's still true. So the loop really looks like this. Over and over and over again. So this would execute whatever's in here 100 times. Every time through the loop, c would have a different value. First time through the loop it's 0, next time through the loop it's 1, next time through the loop it's 2, and so on until we get to 99. Then we bump it up to 100, which is not less than 100, so the loop automatically ends. Java throws in another little curve that probably would have worked in C#, but we didn't use the char type. Remember when we were talking about types last time, that char is a type for a single character. It's different than a string. It is a primitive type, first of all. Notice it's not capitalized, so it's not a class. It's a primitive type. And you can assign characters to it. Characters are surrounded by apostrophes instead of quotes. That's how you can tell a character literal from a string literal. And so this says start with the lowercase letter a, keep going until you hit W. Do not process W, because this says less than W. When we are equal to a little w, then it quits. And what's really bizarre here is look what we do when we walk through the loop. We add 1 to C. How do you add 1 to a character? Easy. Programming logic beginning, I have my ASCII table here. And here are the ASCII representations of those characters. A through W. Behind the scenes, the computer is actually using the number 97. And so when you say start with character A, behind the scenes there's a 97, so when I add 1, it goes to 98. It goes all the way down to 118 and it stops processing. So that's a nice little curve that you can throw in there. Rarely do I need to walk through characters unless I'm trying to generate a web page that looks like this. This was done with a loop. Does the same kind of thing. But rarely do I need to do that. And notice you can print C. This system out print line, by the way, is Java. It says display this output to the console. I wasn't sure if that worked in Android, so I tried it. And I didn't get any syntax errors. And my program ran. This is the output of it. I did that during the break. But what I have yet to figure out, because I can't find it, is how to display the console. Oh, there it is. I think. That's the Gradle console. Gradle, by the way, is just the build process. I don't see a Hello Volker in there anywhere. Let's run it again. Let's see if I can clear this. See if it comes up this time. Doesn't look like it. So that may be a console, but it's not the one I'm looking for. And I looked under View, Windows. I don't see a console there, but I'm getting old. Still the Gradle console, but I don't think that's the right one. I'm just looking for a regular console. If you can figure it out, let me know, but don't do it now. Listen to me instead. If you find it later, let me know. Any questions about for loops? Let's just throw one in here real quick. For, and this is very common, to define the loop variable inside the loop itself. Integer x equals 1, as long as x is less than or equal to 10. Every time through the loop, bump it up by 1. Note the syntax, semicolons. define and initialize your variable, define a condition separated by a semicolon. It's real bizarre looking. Takes a little getting used to. And then the final one is, what do I do every time through the loop to my counter, and there's no semicolon there. You put one there, you get a syntax error. Now that should give me 10 lines of code, 10 lines of output. Notice that every time through the loop, x is one bigger than it was before. If I wanted to, I could say plus equals 5. There's no reason you have to bump up by 1. It's just most common. If I bump up by 5, it'll start at 1 and then go 6, 11, 16, so on. Except I said keep going until you hit 10, so it quit. Notice it doesn't have to match exactly. Typically, you wouldn't say that. As long as this condition is true, so as long as I'm less than 50, it will keep processing. Instead of bumping it up, you can bump it down and work from the top down. You can start at 50 and work to 0. All of that's possible. We'll learn a little later when we start talking about arrays that for loops and arrays go together very well because we put all this data into an array. And we usually want to process it one at a time. Give me the first one, the next one, the next one, the next one. For loops are real good at that. So we'll revisit this for loop a little bit later. Java, just like C#, has a for each loop. Unfortunately, it doesn't have the word each on it, which makes it, for me, very hard to remember. Every language does a for each loop differently. I was listening, I said before, to the recordings from a couple of years ago, and at the time I started sticky notes. Here's how you do a for each loop in C#, here's how you do it in Android, here's how you do it in iOS, here's how you do it in PHP, here's how you do it in JavaScript. They're all different. It's to make life for students and instructors difficult, but in the real world, how many languages are you going to be using? 1, 2? You'll probably be able to keep them straight. So here's the overview. What a for each loop does is it gets rid of the counter. It just says for each one of them, start at the beginning, go to the end. If you want to bump up by 5s, or if you want to start at the end and go to the beginning, you can't use a for each loop. But what we so often process from the first element in the array to the last element of the array, we do that so often that a for each loop was added to the languages years ago. And what this says is for each item in the list, this is the list. This is the syntax. So that's your list, or it's an array, or whatever that you've got a bunch of data in. We'll talk about arrays next year. This is, let's pretend this is an array of cars. Then I would do something like for, parentheses, car. Car is the class. A car, or car lowercase, or just C. And if I have a whole list of cars that starts at the first one, does some processing with that car. Automatically goes to the next one, does some processing with that car. Automatically goes to the last one, processes with that car, and then leaves the loop. I promise to demonstrate this for you. Can't do it right now because we haven't talked about arrays and array lists. As soon as we do, Array lists is going to be next time. As soon as we talk about array lists, then this will make even more sense. Before I forget, some of you are already bored, so I'm going too slow. The next assignment is to convert your monthly payroll into an object-oriented program, meaning I want you to define a class. I'm not going to have time to talk about it today. I want to talk to about 8, maybe a little after. I'll give you some lab time to work with me in the room, so if you have trouble, I can help you out. Or you can just boogie on out of here and go do something else. But what I want you to do is define a class that contains how much did you borrow, what's the monthly, what's the yearly interest rate, how many years did you borrow it for. I want you to add the date. And I will document this thoroughly. I'm just giving you a look ahead for those of you who want something new to do. And the class does all the processing. Remember from Programming Logic Intermediate, you don't do processing in a GUI in main. The class does, the business class, the problem domain is what I'm going to call it here because it's more generic. The problem domain, the business class, does all the processing. Your results should be pretty much the same, but the problem domain then does the class processing. So you'll have to do a little bit of reading. So I'm not going to get that far today, and I'll warn you in advance, my notes are written for Eclipse and I haven't updated them yet. I didn't say my notes were going to be current when I took this class, did I? I hope not. There are some things I want to update. I'll get there. But in the meantime, maybe you can figure it out. Okay. Any questions about for loops? Less used are pretest loops. And even more less used are post-test loops. They look exactly like they do in C#. Keyword is while. Just like an if statement, you put parentheses around your condition. As long as that condition is true, this will loop over and over and over again until the condition becomes false. So somewhere inside this loop, you better do something that changes that condition. These are often used for processing files where we don't know how many rows are in the file. How many lines of text are there in this file that we're sucking in? I don't know. Well, you can't use a for loop. You can only use a for loop if you know how many times you're going to do something. So while it's not the end of file, read something, process it, come back up. You're in the end of file now. Nope, read something, process it, come back up. Every time I read something, I get closer and closer to the end of the file. So I'm changing my loop condition somehow inside the loop. Post-test loop, you ask the condition is at the end. The syntax here I always think is a little weird, but it's the same in all the languages, where there's a do and here's the body. Here's what you do as long as this condition is true, semicolon. And this loops and loops and loops until this condition becomes false. And then it drops out. I can't remember the last time I wrote a do while loop that wasn't an exercise for class. They don't come up very much in object-oriented programming. The difference, again, between the two is here, it's very possible that this condition is false when you start. If this is false, you never do the body of the loop. Post-test loop, we don't even ask till we get to the end, so you're going to process it at least once. And then check the condition. It's the difference between the two. And this was an exercise for me in college, rewrite this do while loop or while loop into a do while loop. Change the logic so that you ask after instead of before. In object-oriented programming, it's exactly what it would be. An exercise just to make your brain work. If we need one, we'll put it to use. I don't see it happening anytime soon. We've already written some custom procedures. Let's talk about those real quick. A custom procedure is just like the one we wrote here, called run code. It's not built into the language. It's not created by Android for you. So it's our custom method is what we called it last year. Custom method. You give it a name. What do you want to call this thing? You also have to tell what kind of value is this method going to return? Void means nothing. It's not going to return anything to you. It might display stuff on the screen, but when this method is done, it doesn't send anything back to onCreate. Like in all languages, we have to designate whether this is a public or a private method. This one should probably be private because it's only used by this activity. If I make it public, then I can share data with a different activity. Remember, activities are kind of like screens or forms, kind of. My advice in the last class in Programming Logic Intermediate was make them private. When you figure out you want to share them, then change them to public because most of them are going to be private. And you can share them if you need to. So here's an example. What's in my notes is kind of the details. It could be public or private. Notice the curly brackets, public or private. If appropriate, you can call it static. We'll talk more about static later. We might remember it from last year. What type of data do you return? That was the void. What's the name of your method? You get to pick it. Now in here, I talk about, is it in here? There's a book I have or had in my office. I don't think I gave it away. Elements of Style. This is a book I got. When did I get that book? Master's program, maybe? So a long time ago. It's still sold today. It still applies today. It's about programming style. Where do you put your curly brackets? What do you name your variables? When is it okay to use a single variable name in a for loop versus a real name? I used X, right? That was pretty lame. When is it okay to do that? How do you name your methods? Elements of Style says your method names do something, so they should start with a lowercase letter that is probably a verb. That's why I called mine do code or run code or something like that. Should start with a verb and then the object. What is it you're doing? If I remember next Monday, I'll bring that book in just to show it to you, and you can try to find it. It's still out there someplace. But it's really pretty. It's very thin. It's about that big. It talks about all the different things that you might throw into your code, and it all still applies today. Really pretty impressive. The other thing a method might have is a list of parameters. We'll see these more later. The star means you can have many of these. Each parameter has a type. Each parameter has a name. Remember last year we were talking about the envelope. When I call Miguel and tell him to do his job, I might need to pass him some information, put stuff in the envelope when I call him. When he gets it, he opens it up. This is data that is sent usually into a method to say, I want you to, generate random numbers. Remember my get random? I want you to generate random numbers between 10 and 100. Or between 1 and 5, or between 100 and 200, or whatever. That method, one method can do any of those, but you have to send it the beginning and the end. You send it those two pieces of information. Get random gives you numbers in between. So those are some examples of those. Again, we'll see many more of these as we go. We built a bunch of them, custom methods, inside of your business classes, and many of them return values as well. So you've seen them. This is just kind of how do you do it in Java. Pretty much the same way. If your method return type is void, you can skip the return statement altogether. We've been doing that so far, but we could say, here's the end of my method, way down here. So return. Perfectly legal, but also optional since you're not returning anything. Most sample code I see today, so I'm going to say most programmers, if you're not returning anything, they don't bother returning, because what happens when I hit this curly bracket? I return anyways. So this is optional. And again, all I'd ask or recommend is that you be consistent. We'll see lots more examples. You might come back to this if you need a little layout, but you'll probably use the existing examples that I gave you. So here's an example, display some history. Here's one that calculates total pay that needs two pieces of input. It returns a double. Calc is the verb. What am I calculating? Total pay. Lowercase c. I need two pieces of information. How much do you get per hour and how many hours did you work? Take those two, multiply them together, return the value. If your return type is something other than void, you must have a return statement. And my final notes here just simply say, if you're going to declare methods in your main activity, which we do, stick them underneath the onCreate, but inside the main activity. That's where we did. So you go after onCreate. I think it's legal. I haven't tried it forever because it confuses the heck out of me. I think it's legal to have one method inside of another. Define it inside of another, but that means only that method can call it, and that just doesn't make a whole lot of sense. Works. So when you define your own in main, tuck them right underneath onCreate, but inside this end curly bracket down here before the menus thing. You should be okay. Okay. This is where I'm going to end, I hope, today. Let's talk about arrays. In English, that everybody else in the class can understand, what's an array? Should have brought my bowl of candy with me. Motivation. See this? There's motivation.
I hesitate to say list.
Pardon me?
I hesitate to say list.
A list, okay. Nice and short. A list of what? I'm sorry? A particular type of thing. Good. They're usually the same type of a list of things. So a list of students, a list of classes, as in courses, a list of max. Yes? But what does that imply? They're all of the same type. So when we're talking about programming, it would be, I hesitate the word to use list as well because list now has new connotations to it. But what it really is a bunch of memory locations, a bunch of variables, all with the same name. If I wanted to store all your names in my program and you didn't use an array, we'd have student 1, student 2, student 3, maybe student 0. So I would have string student 0 and it would say Jess, and I'd string student 1 and it would say Trevor, string student 2, and I'd have 20 some odd variables. Yuck. If I wanted to display all those, I'd have to have 20 display statements. Yuck. And I have to have unique variable names for each one, and I have to remember that Trevor's number 1, not 2, and that might not be so yucky, but I have to remember that. What C#, what all languages allow us to do, and I hope my recording gets on, my voice carries far enough for the recording. Unfortunately, if you're not here, you can't see this, but for the two people that aren't, it will be okay. When we define an array, what all the languages do is give you enough memory for all of them. When we define an array, we have to tell the language how many items are in this array. The key word here is not items, but elements. There are elements in an array, and there are items in a list. Very subtle. We'll talk about lists next time because there are some drawbacks to arrays that lists fix. You heard about collections last year. Remember we had our list box and it had collections. We could add stuff. We could remove stuff from the list box. Those are collections. Those are lists. Those are arrays, excuse me. Arrays on steroids. Much more powerful. So there are elements in an array. When we define the array, we have to tell the language how many elements are in that array. So in this case, I have 5. The array gets a name, students, and the name students is simply a pointer to the beginning of the big chunk of memory that holds all my student names. This memory, as far as I know, is all contiguous, meaning it's all right next to each other. You want 1,000 students, they have a lot of memory. And it's all right next to each other. Could be today, it doesn't work that way anymore, but that's the way I picture it. Each one of these elements has an index. Happens automatically. It simply numbers them. This first one? 0. Why is it 0? 1, 2, 3, 4. Why is it 0? Sort of. There's actually logic to it, though. Computer speak is what it said. There's actually logic to it. How many steps away from the beginning am I here? 0. Okay, so when if you were to say students, and the way you read this is sub 0, the language, the programming language would then say, okay, go to wherever students is and go 0 steps ahead from there. Cool, I'm there. But what if I did 2? Then it would say, jump ahead in memory enough for, what are these, strings, maybe? Right? Probably strings. Could be a whole class, right? Your first name, last name, your program, your age, shoe size, all that important stuff in there. So this could be an entire class. Your program and the operating system keep track of how much memory this box takes. We don't have to worry about it, thank goodness. And when you say students of 2, it says start at students and jump ahead 2 chunks, however big the chunk is. 1, 2, and now we're here. So there's some logic to it. But if you want to believe it's computer speak, that's okay. When computers count, they always start counting at 0. No reason. But yes, they always start counting at 0. The downside to arrays is we have to say at the beginning when we use this that I need 5 elements in the array. How would I know? Well, that's one of the problems with an array. And so if I had a database or a text file full of student names, how many names are in there? Wow. What's the max is what we then usually define. 30. Well, there are more chairs in there. Max 30. So we read. As long as we don't fall off the end, fill it up too much, we can fill up the first 20 with students, and then we have undefined elements after that. Perfectly acceptable. In my notes, I refer to it as a partially filled array. I have a student here, and a student here, and a student here, and that's it. That's all I had time for today. Perfectly acceptable. But the challenge comes in if you're writing code for this to say, you, programmer, are now responsible for remembering how many of those are filled up and how many are empty. Hence, lists. The difference between arrays and lists, also called collections, also called, I love it in Java, array lists, one big ugly word. The difference between them is this is fixed in size, pretty much. You can make them bigger sometimes, you can shrink them, but the processing isn't even worth talking about anymore. These are fixed in size, these are dynamic. Add them, insert in the middle, push everybody else over. What if I wanted to put Sam in here? Now you got to write code to move these over. That's another nice exercise that nobody does anymore, except for the Skyward entrance exam. Shh, I said that. I don't think it's on there. But that's an exercise. We don't need it anymore because we have lists. And lists take care of all that behind the scenes. Really what lists are arrays. With a whole bunch of super processing around them that makes our life a whole lot easier. If we need them bigger, they go, oh, he wants another one. Adds one. Makes the array bigger. Doesn't need this anymore. Get rid of it, shrink it, puts one in the middle. Oh, we know how to do that. It's the difference between arrays and lists. Lists are still indexed. Lists are still contiguous chunks of memory, sort of. The way I picture lists is just slightly different. connect to a box who has kind of, we used to call this a next pointer. Where's my next one? And maybe there isn't one. But if there is, it's over here. And it has a next pointer that points to the next one and the next one. And I used to write code to do this. Oh my God. Dynamic arrays, we call them. Now they're called lists and collections, and they're all already built, and somewhere at the end there's an end, and you're done. Now I want to insert somebody in between here. Oh, no problem. There. Easy on the whiteboard. Try to write code for that without losing, I used to call them astronauts. I want this chain of astronauts, and now I want to put Sam in between these two. So we cut these guys off and they go floating off into space and we put Sam on the end. No, can't do that. You learn how. We don't have to worry about it anymore. We just say list.add. Remember that? Done. Or insert into position 1. Done. Guys are so lucky. And you'll be much more productive than I was. We're not going to talk too much about arrays because they're fixed. But we used them, remember? In business class, we created arrays. Here's the list of acceptable colors, the list of acceptable, what else do we have? I don't even remember. DVD types, right?
Yeah.
We created a fixed array. It wasn't going to change much, so making it fixed was perfectly acceptable. I'm trying to figure out how to get arrays into your next program. Remember that program with the business class that I just told you about? I'm real tempted to come back. All right. I'm real tempted to have you create a list of loans. They're all hard-coded, unfortunately, because I'm not going to have you read them out of a text file. They're still hard-coded, but create a list. I think you need a little bit of practice. All right, so in this language, how do we do it? We define a constant. Here's my maximum number of students. Remember the 30? Because that's all the seats I have. What's the maximum you expect to have? 5. Okay, and then here this says, give me an array. How do I know it's an array? Square brackets. What kind of stuff am I putting in there? Integers. So this is an array of integers. They all have to be the same type. That's the other thing that's different about arrays and lists. An array, all of the elements have to have the same type. In a list, they don't. Those are just links of objects. They can be any kind of objects. It'd be pretty goofy to have some students in there, a couple of cars in there, a few courses in there, a couple of integers and doubles in there. Perfectly acceptable. Just how do you know what's what when you're pulling them out? It's pretty rare. Even with lists, every item in the list is typically the same type or same class. This says, give me a new array of integers that is 5 items big. And now picture my box up on the board with no words in them at all. We've got a 5-item list, I've got an array, that will store up to 5 numbers. This instantiates an array of integers. Remember that lovely word instantiate from last year? Take an object and actually make one. Take a class and actually use it. Instantiate it. Instantiates an array of 5 integers. There will always be 5 integers in there. These notes still talk about documenting all your variables. This year I said I don't care. And these 5 items are indexed 0, 1, 2, 3, 4. There is no item 5. If you try to reference item number 5, you will get a memory exception saying you tried to touch memory in Windows that you're not authorized for, your program crashes. It's your job, programmer, to prevent that from happening, either by writing code that intercepts it if it happens, or by writing code that prevents it from happening in the first place. Here's a different way to create an array. This says, give me an array of scores. And using curly brackets, here's 1, 2, 3, 4 values they could put into that immediately. So I'm going to duplicate that here. You know what? I think I'm going to go to my code here and I'm going to say run, this is really a bad name, but I'm not being very creative today, run code 2. And just so I can find it a little easier, I'm going to put it above run code 1. Private void run code 2, parentheses, curly brackets. Question, do I need to redefine TV? No. It's class level, it's right here. Oops. So this is available to all of my methods. And as long as I run code first, this will define it. So it's pointing to that text view out there. And so in run code 2, I can refer to TV. And I can get what's inside it and do all my stuff. And so I could do something like this, tv.setText. That ought to clear it out. I'm hoping. Except, you know what? Now this doesn't make a whole lot of sense, does it? Run code 2, do all this stuff and immediately clear it out. How long is that going to take? Well, in an emulator, it might even take a half a second. On a device, it wouldn't take any time at all. So I'm just going to save some time. That's, let it go. Because I don't want to have to copy this line. This should clear it out. Let's see if that works. See if we can watch it flash. Grind. Please. I didn't even see it flash. And probably because it's in onCreate. Remember, that's on load, kind of like form load, where it doesn't even show you the form yet. It's doing all this behind the scenes. Then when it's done, it shows you the form, and we filled the text box. Well, we wiped it out. Here, so that worked. It's a good test, though. All right, now what do I want to do? I want to define an array, and let's do an array of students. So I want to define a string array. And I'm going to immediately initialize it with some strings, and those strings go in curly brackets. To the G? Yeah. If you initialize it using these curly brackets, you may not define its size. You cannot. You can't say 5 and put these 3 in there. That doesn't work. This gives you an array of strings that is 3 elements big. 0, 1, 2, and 3. So at this point now, I could say, let's use a for loop. For integer s equals, where do we start? 0. As long as we're less than, as long as s is less than, and I could say 3 here. Why don't I just say less than or equal to 2? You could, but in English, how many elements are in the array? 3. Most programmers will write this code. How many are there? 3. And you'll see, here's why. An array has a length function, property. I don't know it's a property because I didn't have to put parentheses on it. An array knows how many elements it has, but if I look at the length of the array, it's going to tell me 3. They're numbered 0, 1, 2, but there are 3 of them. It knows that. When you ask for the length, when you ask for, I think it's the size of a list, it tells you how many elements are in there. In like human terms, to use Miguel's concept of computer speak and human speak, tells you how many there are. And so that's why this is the way typically it's written. You start at 0 as long as you're less than 3. Bump it up by 1. So here I'm displaying the word student, the number of the student, a colon, then the student's name, then start a new line. But this is a pet peeve of mine. Humans don't count 0, 1, 2. Humans count 1, 2, 3. We programmers should do that translation. So what I'm going to do very simply is put parentheses around this, because if I don't, it's going to concatenate them. Add 1 to S before I display it. I need the parentheses, otherwise it concatenates it and it just makes it S plus a 1 at the end. I don't think it'll do the math first. I could be wrong. Let's find out. Will it let me do that? Syntactically legal, I expect a 0, 1, 1, 1, 1, or 2, 1. Let's see what I get. Once you start concatenating, I'm pretty sure it's just going to keep concatenating, but there could be an order of precedence that I don't recognize here. How about that? Right for a change. So that's why I put the parentheses around it. Order of precedence is now overridden. Do the math first, then display it. It's very simple to translate computer counting to humans, if that's what we want to do. And it's amazing to me how few programmers do that. Let's try that with a for each loop. For loops and for each loops and arrays and lists made for each other. Still for. Parentheses, just like the irregular for loop, but now I give it a type, string, lowercase student singular. And this, I always say in when I type that, because in other languages you'll have the word in. This will go through the entire array, one element at a time. Go to the board for the people listening to the recording. And now what I've done is created another pointer called student. When I hit the top of the for each loop, student points here to the first one. When I hit the bottom of the for loop, it automatically moves here. Automatically moves here. Oops. There. It automatically senses it's at the end. It goes from the beginning at the end. Remember, we defined this array with only 3 elements in it. So the pointer called student, which is an individual student, points to one, then the next, and it automatically quits when it hits the end. However, I don't have an S. So I can't say student 1, student 2, student 3, unless I create my own counter and manually update it every time through the loop. If you need a counter, like this variable S, then you probably ought to be using the old-fashioned for loop. So here, I'm simply going to say ctv append student colon, and then tack on student. Remember, student points to it. There's no index here. Tack on the student, then tack on the \n, and you're done. In most other languages, I think it reads much better. For each student in students. For each student. Every time through the loop, student points to a different element of the array. My current philosophy is if I can figure out a way to do it with a for each loop, I will. I'll use a for each loop. It's when those special circumstances where I can't use a for each loop because I don't want to go from the beginning to the end. I want to start in the middle, or I want to go from the end to the beginning, or I want to skip every other one for some reason. Then I have to use a classic for loop. But in most cases, for each loop is all I need. This should look familiar. That's the way we defined our constant arrays, though I think they were probably read-only static arrays because this is a pointer. This is the way we defined our validation arrays for the different DVD types or the different car shops that we were using. Use that exact same piece of code. Curly brackets and everything, if I remember right. And then we use some built-in list processing, array processing to manipulate those if we needed to. More often than not, we used a for loop and then we concatenate them together, remember, to display our error message. So here's the valid ones. We used to make string from array, if I remember right. We wrote a method to do that. Turned an array into a string. We wrote it. Go through each one, tack it out. This is it, right? Here's my valid list of students. 1, 2, 3. Nothing terribly new here, but a good solid review.
Can you scroll just a little bit?
Up?
Yeah, just a little bit.
Everything you need to see should be there.
It just,
Oh, you just can't see that? Is that what you're telling me?
TV plays it.
Your TV's not working? Did you leave this one in? Or did you comment it out?
No, it's good.
Go up further,
Yeah, just scroll up.
right there.
Did you do this?
Yeah, it's good.
When he declares the type in run code, take out the type.
Take out the type where?
Right under your run code. See,
Here?
his might still have,
Did you take this up?
mine still said
The text view.
text view, so
Yeah,
it
the
wasn't
text
reading
view.
it.
Yeah,
So-
that's his text for TV.
Okay, we'll just take out the text view.
Oh, up in front of it here, you mean?
Yeah.
Still have a text view in front of the TV?
I do.
Yeah, take that out. Because if you put the text view in here, you're defining a new one instead of using that one, and it still works until you try to share this one.
And what did you put up there? By like right up yeah, no.
Thanks, Jess. Good catch. So here I declared my text view pointer called TV. If you say text view down here, this method, run code, still works well, but it's using its own copy of TV instead of the one up above. And so then when you hit this one, it says what TV. It's not defined because this defines a different, there's 2 TVs. And you might remember way back in October of last year when we were talking about variables and scope, I can have 2 variables called TV, one inside, one outside. Yep. Confusing as all get out. Not a good idea, but yes, it's legal. This one is used inside of run code. This one is not, because run code's got its own, but run code 2 doesn't, so it uses that one, but it hasn't been linked to the R thing. That's why it was failing. Good catch. All right, back to the notes. I think I'm about done here. Most of the rest of the stuff about arrays is just useless. Because if you're going to change the contents of arrays, if you're not going to fill them all the way to the top, then don't use an array. Use a list. We'll talk about that next time. Use the right tool for the right job, right? To access the elements of an array, use the square brackets. Yeah, we know how to do that. Here we go. We did that. Here's my loop. Same kind of stuff. Here's another one. What's the difference? Print line score. Oh, yeah, this one just uses length instead of max scores. And length, by the way, if you have a partially filled array, I shouldn't be even talking about it. If you have a partially filled array, length does not tell you how many you filled in. It tells you how big the array is. If you want to know how many are filled in, you got to count. There are such things as multi-dimensional arrays. Here's your first inclusion in that, or introduction to that. I'll spend a little bit of time on this because I want to make sure you understand it. This is a multi-dimensional array. It has a set of square brackets and then another set of square brackets. And this sounds a little confusing unless you do this kind of thing. What if I wanted to keep each of you in your rows? I would have row 0 with how many students in it? None. Row 1 with 3 students in it. So this would be row 1, student 0, student 1, student 2. Row 2, student 0, student 1, student 2. If I wanted to get to Sherry, I would say student square bracket, row 2, student, second set of square brackets, student 2. So it would look something like this. Students square brackets 2, square brackets 2. And what if I wanted to print the whole room? Use for loop. For each row, and inside the for loop, it's time to type this just so you can see it in the recording as well. Brittany's going about time. Okay, we could go in here. Oops. Run code 2. Unfortunately, I don't have a 2-dimensional array, but it would look something like this. For integer, could I do a for each? No, multi-dimensional arrays have to be classic. There's no for each with multi-dimensional array. Take that back, but we won't talk about it today. For row equals 0 as long as we're less than or equal to what? Max rows. That's going to give me a syntax error. I have to make it row. Every time through, bump the row up by 1. Now this is all just sample code, because I don't really have a 2-dimensional array. And now what do I want to do? For each row, I'm looking at row number 1. Just talk about Brittany and she appears. That's magic. I'm talking about row number 1. I wanted to display each student in that row. For integer student, let's just use s, equals 0 as long as s is less than or equal to the max students per row. That's a nice name. Bump s up by 1. And now comes the beauty. I can't test this, but I could say something like tv.append. Quit typing, just watch. The word row followed by the row number, so I'm now in row 0, followed by a space, followed by student, followed by that should be a colon, no, followed by S, which is the student number. So this would be row, going back to Sherry, row 2, student 2, or row 0, student 0. Concatenate a colon, and then concatenate students, sub, row, square brackets, S. It's not going to work because I don't have it defined properly. But this is the beauty of the square brackets. There are 20 people in here in, let's say, 8, 9 rows. This will print them all. It'll go down and say row 0, student 0 is nothing. Row 0, student 1 is nothing. Row 0, student 2 is nothing. Then it comes back up here to this one and bumps the row up. Then I go to this row. And then when I hit this inside for loop, it starts over again. So row 1, student 0 is Jess, row 1, student 1 is Trevor, and so on. Then it goes to the next row, and the next row. If I want to really blow your mind, we go to 3 dimensions. But that's not so hard, right? Could have another section of mobile programmers in Wisconsin Rapids. That's section number 1. This is section 0. Section 0, row 1, student 0. And then I could go to the 4th dimension and add the year. That was in 1995. You can do all kinds of bizarre stuff with this. Very powerful. And then just one simple little loop like this could print them all. Big, huge monster output. So occasionally you'll get these 2-dimensional things. 2 dimensions are easy to handle because they're like a table, rows and columns. Just do a row all the way across, another row, another row. Keep them in the back of your mind if we ever need them. Great. But for right now, I'm going to comment these out and make sure I'm at the end of my notes and then try to be quiet. Works. That was Command / on the Mac. Commented out my text. Okay, quick check of notes and I think we'll be done. You can't initialize, that'd be really crazy. Normally, where's this stuff come from? Database. You fill up this 2-dimensional array in a database. Can I have a 2 dimensions in lists? Oh yeah, you have lists of lists. Later. There's the table I was telling you about, row 1, column 1. Passing arrays, nah. We'll worry about that some other day. Okay, so that Brittany can do something in case she doesn't want to listen to all of this recording stuff one more time. For those of you that are bored, the next full assignment will be to convert your program to object-based. Create a class that defines a loan. How much did you borrow? How much do you pay APR? How many years did you borrow it for? And have the class do all the processing. Add a date to that, because you'll need it once I figure out the whole assignment. But that should get you warmed up. How do you create a class? How do you define setters and getters? How do you make properties? How do you do members? How do you do, I'm not even worried about validation right now. How do you do all that stuff you did back in Programming Logic Intermediate? This is the question you have to start asking yourself as you're learning new languages. All that stuff that Volker and Brent and Bob and whoever taught me, how do I do that in this new language? Next semester, there's a 50-50 chance you'll be learning iOS. We're going to start all over again. How do I do variables? How do I do calculations? How do I do for loops, if statements, case statements? Is it the same? No. What's the difference? How do I create methods? How do I do array processing? What's the equivalent of an array list? A bunch of software developers, chances are good you're going to have to learn 2, 3, maybe 4 languages before you give this up. Unless you decide to become a professional mountain biker or something, and you give up earlier. But if you're going to program for the next 20, 30 years, I predict there's at least 2 or 3 languages in your future. Not to mention how much the current ones keep changing. So those are the questions. That's part of what you're going to be learning JavaScript pretty soon. And if Brent's still using my notes, he's going to be going through the same thing. How do I do all this standard stuff in JavaScript? And yes, it's different. Next semester, PHP. Going to fill your brain with curly bracket languages. To be a super programmer, you should learn Ruby on Rails. I haven't done it yet. Just Mr. Average Programmer. Do Ruby on Rails, another curly bracket language that has all kinds of cool power to it. How do they do stuff? Okay, that's enough for today. It leaves you about a half hour. I'll stay here till 9 o'clock to help you with any issues you have. If you all disappear, I will go home as well. Oh, and don't forget the ticket. Let's do Friday. It's at the beginning of the last recording number 3. To go to the next set of notes, and I showed them to you already, but let's just review here. Go to the next set of notes, please. There we go. Part 2. I wanted to get to these today. I kind of figured I wouldn't, but can always dream. Here's a bunch of string methods that are built into the language. Pick 4 of them, write some sample code, prove that your sample code works the way you expect it to, and then paste them into the wiki. And no, I haven't figured out the wiki part yet, but I'll make a link to the wiki in the assignment. Paste them in there, and then find somebody else's post and read it and make a comment. So it's 5-point assignment, 1 point for each function that you verify and give us an example of, and 1 point for looking at somebody else's and saying something more than, that's cool.
Nice.
Even better. Try that. See how many points you get. Give me an intelligent comment, please, about, hey, we could use that to take names apart, or hey, we could use that to whatever.
Cool. That.
Or I tried that one and I did this a little bit differently, and here's a different example. That would work too. My advice is come up with your own 4 first before you read the other people's, because that's no fun. One of the pieces of grief I gave to people